And we are live. Looking at the last 12 and a half hours of Sunspot 2738. It looks like the leading umbra is degrading a bit, and the trailing umbra is building a bit. So that's quite interesting, but that's not what we're here about at all. We are here about Sagittarius A star. Now, we started this live stream 15 minutes early on purpose because this press release happens 15 minutes from now. And there's a bunch of stuff to cover, and it's not getting started right away. So we're looking at 9 o'clock. So we're starting 15 minutes early on purpose. And all I can say is Milky Way Galaxy team for the win. Check out some weird music we played live many years ago. My best friend, Dr. Sam Afif. If you're watching, shout out Sam. Here's Sam on vocals and me on drums. Bassline by Daniel Nunemaker, aka C4.
I got 89 rat traps. Bottle tail madness of the rats come attack, cause you never know when I'm gonna bring them back. Bubonic plague, bubonic plague, yeah.
I guess I hit a lot of cymbals.
And the rats come back straight from the bionic attack.
Yes.
Wakes up with robotic appendages. Break it down, cause you're 18. They gonna come out of the sewer, dine on your meat and dine on your daughter. Give you the plague with your swords, send you into a rage.
All right, that's pretty crazy. Not our normal musical content there, folks. If it's the first time you're watching, stay tuned. There'll be some less crazy soundscapes happening. That was just a little post happy hour interlude. Here's some more normal stuff for our channel. Which, I mean, do you really want to be normal, honestly? Trying to be super spaced out over here. For your viewing amusement. And we are not ready to go into any content really yet at all, so just get out the epic pen just in case. I doubt I'll need it, but you never know. And hey, thank goodness for keyboard shortcuts, right, folks? Make more content. So this is the same time frame here at 171 angstroms. Looks like a little flaring going off there, actually. And let's see, we're looking at 8:49 a.m. So I'm looking to be back by 8:55. I'm not going to write anything on the screen. Tell your friends. I will be in the chat momentarily. We'll talk about black holes before people talk about black holes, and then we'll talk about black holes even more. And then we'll talk about fountains. And maybe we'll talk about fountains and black holes at the same time. That's foreshadowing, folks. multicellular nature and all. By the way, folks, this track is available at soundclick.com/goldencatproductions. All right, let's turn this stuff down here. Highly recommend Winamp and Global Controls. Gain control over your computer. Stop using software that is owned by companies that are spying on you. Nobody in particular. Nope. Nobody. We're not talking about anybody in particular here, folks, but make sure you don't get spied on by anybody. All right, so anyway, there's the sun. That little local yellow dwarf. A lot of people don't pay any attention.
Step down.
Here's a 304 angstroms view from the SDO for all you new viewers. I saw a bunch of people watch the morning video. I must have put the correct tags in. If you don't subscribe, you may not get all the videos, folks, because if you're only subscribing to tags, we don't tag the same stuff every day. So tell your friends. Some of this data, we're gathering it so other folks don't have to. They could just watch our videos. Anyway. See what's going on with the magnetosphere. So this is all about black holes right now, folks. We're going to be getting a press release from the Event Horizon Telescope, and it should be interesting to say the least. We're going to attempt to put it in a window and have full audio and not get banned all at the same time, because I'm going to basically talk over them whenever I feel like it. Let me get the chat open so everybody can interact as this press release happens. And we already have the tab open for that. There's your countdown. We're at 3 minutes and 30 seconds. Oh, sure, you can remind us. That would be great. Am I already tuned in? I don't know. Hey, how about if I subscribe? Okay. Yeah. Here's a magnetosphere movie. If you're wondering what was going on with that, that's the situation. All right, so who wants to shout out some black hole facts? Facts, figures, trivia, myths, rumors, remarks, disbeliefs, misbeliefs, confusion. Who wants to send hate mail to a black hole? Oh, poor Facebook. Facebook, we feel sorry for you. You should fix your software. People will like you better. Just saying. Here at this channel, we like to tune into our own videos. If we click on the right things, we really enjoy that. So, who knows some extragalactic or some galactic level cosmology facts? Galactic level cosmology facts, anybody? I was just playing an ad there that wasn't the right ad to be playing. How do you like that? There's quite a few ads. Hast thou seen an ad? By the way, this track is called VC9 January 2008 exclusive promo track. That's not a very creative name, is it? All right. So I'll bring out the pop-out chat here and converse with whoever's here. Which continent are you located on? Which galaxy are you in? If you're one of those Andromeda people, all I have to say is and the conference has already started. We're missing part of it. This doesn't look like anything. All right, I'm going to keep the music going because nothing's happening. Do not ban us, YouTube. This is part of our normal content.
Good afternoon and welcome everybody to today's press conference where we will unveil the results achieved by the Global Scientific Consortium Event Horizon Telescope, which aims to capture the first image of a black hole. A very warm welcome to all of you, especially those who have traveled from across Europe to be here today. We have very little time before the actual announcement goes live across the globe in 6
All right, there we go. I think we're good, folks.
We'll break with protocol a little and hand the floor directly to European research.
We're only taking up, what is that, 1/10 of the screen?
To the 5 leading scientists here on stage with us involved in the discovery. Commissioner?
Thank you very much. Let me put the timer. Thank you so much, and it's a great honor to be here today. We're really about to announce a huge breakthrough for humanity. We are about to take a picture of something that one man alone, dreamt, imagined 100 years ago in 1915. Albert Einstein. Imagine that. This idea that a very big weight transforms geometry, that when the mass is too heavy, you make a hole, a mysterious hole, where nothing can get out of it, where all is absorbed. Michael Kramer here from the ERC said the history of science will be divided into the time before the image and the time after the image. And you know, for my generation, it's all about the imagination of something that was in between science and fiction. At the age of 9, I went with my father to watch the movie Black Hole. And I remember coming home and for the first time in my life, 9 years old, thinking about what's the meaning of life? What am I doing here? Is there any parallel universe? That's what really got me excited. And probably the question that we have to ask.
All right, let me turn this down for a minute. This guy's talking about his history in science.
What about in 100 years?
And we appreciate that very much. However,
100 years ago, but in 100 years,
we don't want to let this play for too long here. When we get back to substantive stuff, we're going to come back. So I'm going to let him play at a very low volume. You may not be able to hear it, folks. I'm going to turn the music back on for a minute.
Useless knowledge. And Einstein could not imagine. He could not imagine what he discovered. he cannot imagine that one day, because he created and discovered the antimatter, that will create the CAT scan that will save lives.
And we're going to drown that guy out for a minute. Because he's talking about how much he likes science. And I'm sure you guys like science pretty much too. Otherwise, you wouldn't be watching the channel. Now, keep in mind, this live stream is going to be viewable after it's complete. So what we want to see are the results here. And we have no idea how long this is going to last. So we're going to head back to this in a minute. There was a couple of things we wanted to look at. So we wanted to see what's going on with the gong too. We got serious bandwidth issues. Let's stop that whole process and just cut back. YouTube, please do not ban us. We're trying to have appropriate reactions to this. And I need to bring this out and the chat. Let me see if I can get everything on the window at the same time, people. All right, let me just turn this down. Cheers to Kalo Jan and reviewer. And how do you pronounce that? Review. Ooh. That's another great name. Almost as good as Korgrog Grogo. Alben Brummett. 10 minutes. Yeah, I don't know. This guy's just talking about science. And I don't want to play too much of it because I don't want to steal their content. So we're going to show whatever they show. It sounds like he's introducing somebody. Now, if we have any difficulties here with bandwidth or things like that, I do have an extra phone on a tripod. But for now, we're not turning on the webcam. Although the webcam is in effect. And, oh, we got a new speaker. Let's see who this is and what they're going to say.
Now I have to fill the time, actually, until we're allowed to actually, start the unveiling.
And they are going to take their time. And I don't blame them, depending on how important this is. Will it be a dud or will it be a thud? In the realm of cosmology, folks. All right, I think this is legit. We've got interactive content here. Oh. All right, I think we are good. We may get insta-banned if you see the stream cut off. Well, you'll still be able to find us if you look at the links below this video. So we've got some music, some original tunes playing in the background there. That's Dr. Steelshank, which is an homage to the singer featured in the beginning of this video, Dr. Samir Afif.
We are looking into space toward the galaxy. Billion light years away from us. 5 billion kilometers away. Where do you see galaxies? A streak of light, which is plasma shooting out of the center of the.
Oh, geez. I don't know what I did.
Marking the supermassive black hole. I never believed that this black hole was as big as people said until we saw that. This is the nucleus of the galaxy M87, and this is the first ever image of a black hole.
There's the unveiling of the image, folks, of the, quote, black hole. Okay. Are they serious? They're kidding, right?
This is the first image of a black hole.
C'est la première image d'un trou noir. What you are seeing here is the result of many, many people working together. You have probably seen many images of black holes before, but they were all simulations or animations. And this is so precious to all of us, because this one is finally real. What you're looking at actually looks like a ring of fire. And it's actually created by the force of gravity, by the deformation of space-time, where light actually goes around a black hole, almost in a circle. And that creates...
All right, folks, they're looking at a black hole in M87 galaxy.
It has a diameter of... I forgot the number, actually.
Let's...
100, no, it's 100 billion kilometers. I got it right. It has
we were told that this was going to be about Sagittarius A star. So I don't know why they're talking about.
It actually appear as a mustard seed.
I don't know why he's talking about
Galaxy
M87, active galactic nucleus M87. I don't know why that's got anything to do with anything, because this whole thing was supposed to be about Sagittarius A star.
Directly what the mass is, and it's 6.5 billion times the mass.
They think the mass is 6.5 billion times the mass of the sun.
That we see there.
Allegedly.
We see this dark region in the middle. I've also been asked by my colleagues, or told by my colleagues, you cannot see a black hole, can you? They're right. You cannot see a black hole, but you can actually see its shadow. And that's when the light actually disappears behind the event horizon, creating that dark region, that dark shadow we see there.
We're talking about a fundamental misunderstanding of everything from redshift to mass.
Behind that image, we're looking at a region
to a photon
that we've never looked at before, a region we cannot really imagine being there. It feels like really looking at the gates of hell, at the end of space and time. The event horizon.
By the way, folks, black holes act like fountains. I don't know if you're aware.
But it's also important for physics. I think my colleague Luciano Rezzolla will now continue and explain to us why this is so important.
I believe what they're saying is that this is lensing, and we are all the way into the weeds of general relativity here. Let's see what they say next. I think this is more polite.
So black holes are part of our daily knowledge. In fact, even a child knows what a black hole is. And the best definition I've received actually comes from a child who simply said, well, it's just a hole you cannot fill. So they're very simple, but they're actually extremely problematic in physics, and because of the properties they have. The
or don't have.
Is that at their center, in a single point, we think the laws of physics break down. We call this point a singularity. Another property is that this singularity is covered by a surface, a mathematical surface, which is called the event horizon. Gravity is so strong on this surface that nothing, not even light, can leave it. And this surface separates the interior from the exterior, and nothing from the interior can leave and be transmitted to the exterior. And for a scientist, this is a drama, because scientists want to know everything about every corner of the universe. So having a region where you say you cannot experiment there, or you can experiment there, but you cannot tell them.
He's talking about science itself. Let me shut him down a minute here, because
and the same puzzling thought
he's just talking about science. And
so how do you get to terms, you come to terms with this idea? Well, the first thing you want to do is convince yourself that black holes exist, and in particular an event horizon exists.
The first thing you want to do is convince yourself that they exist for some reason.
So you may wonder, how do you know it is a black hole? And it is because it matches extremely well with the prediction that we can do from theory. And this is shown in this picture over here. So on the left, there is the observed image. On the right, there is a theoretical prediction. And as you can see, the analogy is remarkable.
Let us know what you think, Milky Way Galaxy
As a matter
team.
of fact, we have carried out
And
over
if you
these
got
past 6
Andromeda
months
Galaxy or
the
M87
most
people
extensive
or Cygnus A Galaxy
investigation
folks,
of what happens
please
to
type a
plasma
comment in
to
there
matter
because
as it falls onto a black hole.
we're interested in your
We have
theories
used
also.
supercomputers and highly advanced numerical codes to calculate what happens.
All right.
And what we've learned is that as matter falls onto the black hole, it will start rotating at speeds which are close to the speed of light and will become hot and emit light, especially in the radio frequencies, which are the ones that our telescopes can capture. But these immersions are not sufficient. If you want to know what a black hole looks like as an image, you need to take into account that light doesn't move on straight line near a black hole. Just contrary to this room, light can come from all sorts of places. And so light can be bent, can be lensed. And so the image that you obtain by looking at a black hole can be very counterintuitive. And
it's so counterintuitive that it doesn't look like a black hole, but they're going to try to figure out a way that it's a black hole.
Of synthetic images, which cover all the possibilities that we think are realistic conditions under which a black hole is formed. And this is how we have come to conclude.
Hey, folks, look.
A black hole as predicted by Einstein.
High-end bicycles.
You may ask, what is the meaning of this discovery?
Were you aware that the Wright brothers were a bike shop before they invented the airplane?
We have transformed
just saying.
A mathematical concept.
I don't know if it's related. Anybody?
Something that I normally write on a blackboard when I lecture on this into a physical object. Something that
Einstein wrote bikes too. And even Einstein knew Einstein was no Einstein. That's a quote from Einstein.
And you may think this is a minor thing. Actually, this is a fundamental.
Oh my gosh, what happened?
In any scientific progress. It's a scientific.
I'm not trying to play games here to mess with the algorithms, YouTube.
Make an experiment and
I'm trying to get it so it fits on the screen right without jumping around. And I apologize, viewers.
And I will leave the word.
There's a lot of stuff going on at the same time here.
How this beautiful experiment
perhaps more. Oh, jeez. I don't think that guy said anything. He said there's lensing and we know about the lensing and blah, blah, blah lensing. Here's a look, there's lensing.
Thing that you do just from your desk. In many cases, you have to embark in an expedition. And 2 years ago, a large team of astronomers embarked in expeditions to the most remote places on Earth, in places where the atmosphere is thin and dry, because we need to observe at the wavelength where the atmosphere is important.
Now, folks, I didn't make this video to make fun of these people, all right?
In these locations,
they need to be embraced into the upcoming scientific paradigm because they are making important measurements.
With European technology. And in these telescopes, the team of astronomers went there prepared with one eye into the weather forecast, checking up.
Let me see if he actually gets anywhere. We'll just listen.
Checking that everything works.
And I'm going to switch. I'm going to shut him down actually entirely. And I'm going to switch to we're going to use DuckDuckGo to do some Google searches. We're going to not Google things. How about that? Let's see. So let's talk about black holes while this guy bloviates. And again, I'm not trying to defame or discredit anybody. I have no idea what anybody's credentials or studies involved. Here's a nice diagram. And it's not a diagram. How dare you trick me like that, PBS? Oh, here we go. That's a good image. Now, the underlying effects that cause a thing like this to allegedly do what it does are in deep, deep question. So there are a lot of issues with standard cosmology, including problems with things like redshift, the inability to find any dark matter, and the fundamental idea that gravity is the governing force in the universe. let's go back to this guy.
to image. We can
See what he's saying next.
information from this precious data.
He's talking about
which
imaging.
occupies
Let's see what he's got to say.
6 cubic meters of disk, as I said, to get something like the image you have just seen now. And to know how you extract this information and you get from that, my colleague Monica Moshibrowska will show us.
All right, let me get the chat out. We'll have many things on the screen at the same time. It'll be great.
You may wonder how this image was made in the first place. Event Horizon Telescope data is like incomplete puzzle set. We actually only see pieces of the real true image. And then we have to fill in these gaps of these missing pieces.
Trying to get the windows to fit, folks, and leave as much information on the screen as possible, and keep this condensed, and not cover anybody's face.
This is actually a very difficult process. Therefore, the imaging process has been split into several phases. At first, at the very beginning, we were working on this imaging completely alone.
And we really want to see what the images are, folks, so
this
is super important.
Almost life-changing.
And if you're not aware, I've been waiting for this for 25 years.
Popping out on the screens of
because there are massive issues with astrophysics.
We form independent teams that work completely independently from each other to repeat the imaging process. This was very necessary, important step because we wanted to get rid of the human bias as much as possible. And in the last phase, which took the longest time, the imaging was done very, very carefully via very careful scientific analysis. So what have we learned from the images?
Now, for those of you who are not aware
also from the data
of what this is one extremely sophisticated setup here, the Event Horizon Telescope.
We observed the source for 4 days. Over the 4 days, the ring is there. The image looks almost exactly the same.
It's multiple radio telescopes around the world.
Over 4 days, the size is always the same. It doesn't change. We also measure the contrast.
And she's got some serious, this is some serious data we're talking about here.
The contrast is as large as it is expected.
The question is it a black hole? And is a black hole a thing?
About this ring. It's not really a full ring. It actually is much brighter at the bottom side. Why is that? Our models told us immediately that this kind of structure can be only formed if something in the source is rotating. What is rotating? It could be the black hole, but also the matter around it, or both.
It could be the black hole, the matter around it, or both. Exactly.
To actually estimate or calculate the exact speed of this rotation. But these images give us a sense of the direction of the rotation, which is clockwise in the sky. So to summarize, our images, our data tell us that we are looking at the shadow of the black hole, which has been predicted by all the models of the black hole that we have developed over the last few decades.
All right, so I don't think they're talking about lensing. Doesn't sound like lensing to me.
Share some final remarks on the current.
And I'm pretty sure there's going to be no lensing. So let me go out on a limb.
Thank you.
And say that this does not prove relativity. I don't think it disproves it either. But general relativity, I'm not so sure it's real.
It's a very ambitious project, but one with a very clear
I'm sure it's a real theory.
We want to image for the first time the central black holes in the galaxy M87 and in the Milky Way. Today, now, 6 papers are appearing in the Astrophysical Journal Letters, a special edition, that show the image and all the discussion that is needed to convince our scientific colleagues. And in a few days, the data from our observations will be made public so that scientists anywhere in the world can verify our results. So how have we made this happen? We had to assemble a fleet, a capable fleet of the best and most sensitive millimeter wave radio telescopes in the world, combined to supercomputers to form one large radio telescope. We had to organize a team that now numbers to more than 200 scientists from many institutions around the world. This is a truly global collaboration. We cannot name all the people that are participating in this, but representative for all of them, I want to recognize Colin Lonsdale,
All right, YouTube, please don't ban us. We are. we assure you, this is part of our content.
Together with our other friends here, the global partnership that we have, all the people that now are listening elsewhere.
I am trying to get some Facebook.
The preparation for these observations took a long time. I spoke this morning to somebody who started 40 years ago building millimeter telescopes. And so you can say several decades of preparation went into what in 2017 was for the team a very, very difficult, a complicated experiment to perform. This experiment was successful. This story is not a story of one hero. Instead, there are many heroes to this story. We work with these people and we salute their achievement. A number of them are here in the room today, ready to meet you later. So in Europe, how were we able to play a leading role in this endeavor? Foremost, it is through combining forces. We have brought together astronomers, observers, theoreticians, and facilities. Together, we in fact were able to make a much better result than we would have been able to do individually. Of course, in Europe, we have direct access to some of the most powerful millimeter wave radio telescopes. The Institut Radioastronomie Millimétrique ERAM's 30-meter telescope was a crucial element in the north. ALMA, the Atacama Large Millimeter Array, where the European Southern.
So what he's doing right now is he's rattling off the different telescopes.
It was absolutely a game changer. It enabled us to get the sensitivity and the resolving power to make these images happen.
He's talking about the different radio telescopes that are used to create the images. We need a lot of telescopes.
Have collected the capabilities, have developed methods, have acquired the.
We need a lot of telescopes in order to corroborate the data, because Earth-based telescopes are measuring things through a lot of radiative fluctuation.
To build instrumentation, state-of-the-art instrumentation that we need.
So it's very expensive to build space telescopes, and Earth telescopes have to view things through the atmosphere, and then they have to corroborate all their data. It's a very, very complicated process. And I cannot change the size of this window. There we go.
The European Research Council and from RadioNet was crucial in making this excellent.
And we love the Brave browser. If you've ever tried it, check it out. It's a great thing. It will not track you.
So where are we going from?
All right, we're going to shrink this guy down, and until he says something important.
87 in the bag. We're confident that very soon we'll complete the analysis of Sagittarius A star. We will go back to observe, and so please stay tuned. We'll come back. We are already underway improving the array. Foremost.
He said Sagittarius A star. I heard it.
Expanded Noema array that they will soon finish will again be a game changer for our trade. ALMA will offer us improved capabilities, and the Greenland telescope and perhaps the African Millimeter Telescope project will make critical contributions to improving the quality of the EHT. With all of this, we're well placed to go into the next step of this journey. I think that we will be able to confirm a lot of the science that we're expecting.
Well, let's see what happens.
But much more important, we will be able with this machine to make discoveries of the unexpected. And that's the most fascinating in science. I personally like to say that I will think of a time before and after I saw for the first time this image. I mentioned this also. Today, I believe for all of us marks the beginning of the day after for all of us. Thank you very much for your support, and thank you for your interest.
Well, we hope the science advances. Regardless of what it leads to, we are going to call them like we see them. This guy didn't really give us any information either. Let's see if any information gets released. Besides what M87 looks like.
Our session will always be open for such extraordinary announcements. Now we can turn to your media questions. Let me point out that we've
That's the announcement.
Not only press material and
all right.
words, but
that was a little bit anticlimactic, folks.
Website. May I please ask you to introduce yourselves by name and media, starting
seriously
in the middle?
Let's see if they get some good questions. Maybe it'll turn into content. Who knows?
Thank you very much. My name is Nicholas Wallace. I'm policy editor of Science Business. My question is for Commissioner Wallace. You said that this is the most excited you've been since you took office in 2014. My question is, do you expect any more excitement before your term ends? And if not, given that this was an international project that the Commission contributed to, what should be next for the EU and international collaboration in science? What do you think the next big thing should be for the next Commissioner? Thanks.
Thank you very much for the question. Yes, I think that this is really the pinnacle. I mean, I had exciting moments, exciting political moments.
He asked him a bureaucratic question. Boy, that's fascinating. Thanks. What now that you've conquered the universe, what will you conquer next? The multiverse.
About it at the time in a positive way.
He's going to conquer the multiverse now that he's conquered the universe.
And the council, and we discussed, and a couple of weeks ago, we achieved really something unique. Is that we had that agreement with the countries and the parliament for
all right.
the content of that program of the future.
Let's let him talk in the background and then look at some science stuff.
Answers your question, which is that is link between the citizens and science, and how important is that? And so we want to define this idea of the missions, the mission-driven science, because we want European citizens to feel connected. And that connection that happened here today, it's a proof of that. You know, I've never seen this room so full, or if I've seen it, was not for positive reasons or for reasons of crisis, and not for positive things. And it's so refreshing.
Oh my gosh, did he get cut off? Was that so refreshing, or was it my imagination? Oh, no offense, no offense. By the way, shout out to Oppenheimer Ranch Project if you're tuned in. Cheers. I don't know how you got demonetized, but you're still on the we recommend list, along with some other folks there. And that is in random order, by the way. So if you don't see yourself, you may still be there. Just check it out. How about some music nobody ever heard before in their lives? Such as
the Sanctuary Chapel.
Such as the Sanctuary Chapel. I honestly don't know what it is. I really don't know. I have some idea. I don't think it's super controversial, and I don't think it'll get me banned from YouTube. Whoops. Oh, hey, there's music. How about that? I got the volume up a little too high, folks. So, hey, what does everybody think about black holes? Do they exist? Or black holes, you think they're a thing or no? Please leave a comment as I attempt to find a song that I want to play. And just report some actual science stuff. I guess they got a photograph of a torus, I think is what they were trying to say there, making a big federal case out of it. The hell happened? We had a train wreck. That's what you call a train wreck in the DJing world, folks. Volume. Oh, it's a volume death. Let's play something a little bit more coherent. On a related note, thanks for joining the chat, smAsho staff. That really is smAsho staff, by the way. That's not a heckler. Although we'd appreciate it if we did have a heckler. I don't know what the hell I just pushed there, but there we go. By the way, if you haven't checked it out, check out helioviewer.org. Know what's going on with the sun. I didn't mean to click the Soho. and tease you. I don't want to tease anybody with the Soho. So helioviewer.org is where you get this nice Earth scale thing, and you can generate movies. It's very nice. So there's the Earth scale. Let's look at the colored magnetogram. Actually, you know what? Hey, let's look at the real-time solar wind. Cheers. By the way, this is all based on measurements. And it's not based on any math in search of observations. And since we made a video earlier today, let's look at the last 6 hours. And do we have any requests? Because this stream needs to end as soon as possible. Comments. Let me get through. Oh, geez, we got a lot of comments. Hey, thanks for joining, everybody. I really appreciate it. Sometimes we report on things that aren't really an emergency, but seem like it because other entities claim it is. And I prefer not to have my credibility damaged, but I'm not too worried about it. Oh, it's a subliminal message. Oh my gosh, what happened? Here's a colored magnetogram. And that trailing portion is gaining complexity. So this sunspot is gaining in danger levels, by the way. Final segment before we get out of here is we're going to look at some transient analysis of some of our favorite objects. So while you check out what's going on in the magnetogram with sunspot 2738, we're going to show you some bat telescope analysis. So some radio telescope analysis of objects all around the universe. New viewers are probably not aware that a galaxy hundreds of millions of light years away is the strongest radio source in the sky, second only to the one you're looking at right now. So we're going to look at some transient analysis of all of those in just a moment while I load up the bat telescope. So give me one moment. We're going to look at the actual emissions of Sagittarius A star and some other local radio sources, because I don't call them black holes, and I haven't called them black holes for the last 25 years. I call them massive radio sources. And there's a reason for that. So let's look at some transient analyses here, where we are reading actual data. We're going to put this link in the description of this video before your very eyes. It keeps telling me I'm screen sharing, as if I have anything to hide. Oh, Google, don't police me, Google. No, please. I'm so scared of you. Oh, you're a multi-billion-dollar corporation. Oh, look at that. We got a nice plug right there. Whoops, I didn't go to studio. Oh, never mind. I don't think I have the edit screen open. Now, never mind. I'm not going to do that now. But this will be in the description after the video. So if you're not viewing this live, chances are you'll probably see this link right here to the Scaled Map Transient Analysis Synopsis. Yes, that's right. The Burst Alert Telescope. Actually, that's not the right page. Okay, I think it's this one. Let me see. Nope. This is what happens when you don't send yourself text messages on the computer. What the hell? All right, let me just get the right web page here. Maybe I've never looked at this on the computer. Okay, Swift. We are now getting into a government quagmire. And geez, that's quite a long URL. All right. So what we're doing here is we're looking deep into cosmology. We're looking for the transients, which is a measure of the sudden bursts of things like Cygnus X3, otherwise known as Deneb. Maybe I can find this by searching on DuckDuckGo. Now, for you new viewers, if you're going to search through a bunch of government data, part of the reason why we do our videos is because we have these links, because there are certain things that are very important in the sky that we're looking at. Now, Cygnus X3 is known as the star Deneb. It's the North Pole star at the other end of the precessional cycle. So for you catastrophe theorists, you may, oh geez, you may want to note the fact that according to this data right here, Deneb just flatlined. So if you want, and I didn't even draw that there, that was just there, I guess, by divine providence. That is what this thing does right before it has a massive outburst. I've never seen that before, and if anybody can verify if that's normal, please let me know. It sure looks anomalous, but yeah, it looks like the last 5 days have turned into a real mess. Now, Cygnus X3 is another, quote, black hole or neutron star or quark star, or they have a million theories as to how this thing does what it does. If you're not familiar, please read up about Cygnus X3. It's fairly well known. It's one of the most well-known cosmic ray sources. It has a periodicity of 4.83 hours. Here's the main transients page I've now copied, and I will paste into the description after this video is done, which will be as soon as possible. Now, if you want to look up stuff here, all you got to do is go to this page and then click Find. So right now we're looking for Cygnus A. And you just type Cygnus. And you got to know how to type. You get a lot of results. And okay, you type Sig. Here's Cygnus X1. This is a common, quote, black hole. This is the one that Stephen Hawking and Carl Sagan had a bet about. And we're going to keep calling it a radio source. So there's another radio source from within the Milky Way galaxy. Just keep in mind, the galaxy that they showed there was M87, which is a giant distant quasar. So it's got nothing to do with Sagittarius A. But let's look up Sagittarius A anyway. And I'll show you how to do it, and I'll leave the link again in the description. It's number 688 for some reason. And there is the transient analysis of the, quote, local supermassive black hole, end quote. And I would note that there is an extremely low count right here, and I wouldn't freak out about that because it's not a big deal. So anyway, hey, thanks for tuning in, everybody. I realized it was a little bit anticlimactic. We'll give you one final view of the local yellow dwarf, and then we will get the hell out of here because there are a lot of things to do. And by the way, you should also get out of your comfort zone and do some stuff that you suck at, because it'll never be now again. Here's a 94 angstroms view. We see a little bit more North Pole coronal hole in the past few hours, actually. And we see some little plasma sprites going on there. Let me break out the chat because I have no idea what anybody's saying. Who is here? Thank you, everybody, for joining, by the way. Let me try to get to the bottom of this. And when I say this, I mean the chat. By the way, please share these videos on your social media, wherever they are, whether it's mine or Facebook, or send links through emails, or do whatever you can. There's a lot of stuff in the description, other things to explore, check out, and donate to, because there's a nonprofit organization forming right now. And by the end of the year, your donations will be tax deductible. Let's see. There's a lot of money being spent in the areas of space exploration and astrophysics and so on. And it's pretty crazy. So thanks for tuning in, everybody. We are out of here. Expect your standard early morning space weather video tomorrow. And may the solar wind be at your back and the atherosclerosis absent from your arteries.